Okay, 3.2b is a review of exponent laws and then negative exponents. Okay, exponents. So an exponent indicates how many times some quantity is multiplied by itself. Okay, so for example, if we had b to the n, okay, the b would be the base and the n would be the exponent. Okay, and then b would be multiplied by itself n number of times, and we call that n factors. And of course, n is a positive integer. So b can't be multiplied by itself a fraction number of times. It's going to be a positive integer number of times. Okay, I'm going to give you just an overview of all the exponent laws, and we've done these since grade 9. So product law, this is when two numbers of the same base, so for example, x and x, are multiplied. What happens with the exponents are, like, we end up adding them. Okay, quotient law is when we have two numbers, again, with the same base, and they're divided. What we do is subtract them, and we always subtract numerator minus denominator, or the first one, so a minus b. Okay, power to a power, or power of a power rule. When a number with an exponent is raised to another exponent, what we do is we multiply them. So x to the a to the b would be a times b. So that would be the new exponent on your base. Okay, power of a product law. This is when, say for example, we have two numbers inside of a bracket and they're raised to some exponent, in this case b. This exponent b applies to each number individually. So x to the b, y to the b. Okay, just notice there are no addition or subtraction signs in the bracket. So the number in the bracket is a monomial. Okay, it's not a binomial or a trinomial, it's just one number. It has to be multiplied in the bracket. Okay, we reviewed this one already. Zero exponent law, any number to the 0 equals 1. Okay, except for 0. We don't deal with that in high school. Okay, now this one actually may be a new one, negative exponent law. Okay, so it is touched on in grade 10, but more of a focus in grade 11. So what happens when we have a base to a negative exponent? We do two things, okay? So first of all, we flip the base. So flip the base, and it says it in these words here, but I'm going to write it out, numbers 1 and 2. So this 1 over x actually becomes, oh sorry, this x over 1 becomes 1 over x. So see how it got flipped? So flip the actual base and then raise each number. Okay, we would raise each number to the exponent. So in other words, like this may look like this, like 1 over x all to the exponent b. But we know that 1 to any exponent, so say it's 1 to the b over x to the b, this is just going to simplify to 1. Okay, so this is the simplified version. Okay, and we know that the denominator cannot equal 0. So there is a restriction on that domain there. So the number 2 is that we change the negative exponent to a positive. Example 1, simplify using exponent laws. So everything here is multiplied. So normal numbers, we multiply normally. So we get negative 6. And now if we have the same base, so a squared and a cubed, what we do is we add these exponents. So I get a to the 5. B to the 1, okay? So if an exponent doesn't actually look like it's there, it's to the 1. And b squared, okay, add these exponents, we get b cubed. Okay, b, m to the 3 to the 4 to the 2. All of these numbers, this is power of a power, all of these numbers are going to be multiplied. So 3 times 4 is 12, times 2 is 24. That's it. Okay, C is going to be power of a product. So because this is a monomial here inside the bracket, we know that every single term inside this bracket is going to be raised to this exponent 3. So the negative 4 is going to be raised to the exponent 3. That's just normal. That's on our calculators. We get negative 64. X cubed is going to be raised to the exponent 3, so we multiply x to the 9. And y squared is going to be raised to the exponent 3. We multiply, we get y to the 6. Okay, D and E are very similar. What you want to do is step 1, you want to do the numerator, and then you want to do the denominator, and then you want to divide. So numerator, denominator, then divide. So let's do the numerator. This is the only x term, so it's x to the 4. Y to the 3, y squared, we get y to the 5. And then z to the 4. And in the bottom, nothing can simplify because we only have one x term, one y term, and one z term. Now, everything here is divided. So we're going to take the top numerator, or the top exponent, and we're going to subtract the bottom exponent. So for the x's, it's going to be 4 minus 3, which is 1. For the y's, it's going to be 5 minus 4, which is 1. And for the z's, it's going to be 4 minus 1, which is 3. Okay, so same approach for E. We're going to calculate the numerator. So negative 2 times 8 are just normal numbers. We get negative 16. We only have one x term, which is x squared. Now the y term, we add the exponents. 1 plus 2 equals 3. Now do the denominator separately. 2 times negative 2, I get negative 4. And then we have x and y, and those don't multiply by anything. Now we can divide. Negative 16 divided by negative 4 has nothing to do with exponent laws. These are just normal numbers. So negative 16 divided by 4 is just 4. X squared divided by x, so 2 minus 1 is just x to the 1. And then for the y's, we do 3 minus 1, and we get y squared. Okay, for f, we can treat this like the numerator here is all squared. Okay, another way of doing this, instead of applying the squared to each, we can just write it out 2 times if you really want to. Okay, and then the denominator, 8y to the 4, 8y to the 4. So you can write out each of these twice. So this squared applies to both the numerator and the denominator. It's because this is technically one number. So 6 times 6 is 36. X to the 5 times x to the 5, we add them to 10. Y to the 3, y to the 3, we add them to 6. 8 times 8 is 64. Y to the 4, y to the 4, we add them to 8. Okay, so 36 divided by 64, I use the ABC button in my calculator, and we just reduce. Okay, so this doesn't add or cancel out precisely, so we get 9 over 16. In other words, we can divide both the numerator and denominator by 4 just to get a simpler fraction. Equivalent, but simpler. Okay, x to the 10, we have no other x values here, so we just leave it in the numerator as it is. Okay, and this one's a little bit different. Y to the 6 over y to the 8. If we were to subtract these two, we get y to the negative 2. Okay, so this is part of our new law. What we basically do is we take this y and we put it into the denominator because it would be 1 over y squared. A cheat way of doing this is being like, okay, y to the 6, y to the 8, I actually have 2 more y's in the denominator. So it's going to be y squared, but in the denominator. Okay, express each power with a positive exponent and simplify. Okay, so for the first question, for A, we see that we have a negative exponent, so negative 2. So what we want to do is we want to flip the number, okay, or flip the fraction. So I'm going to go ahead and flip this, and we get x to the negative 3 over y to the negative 2. But this time, we raise it to a positive exponent, okay? So there are those two steps. So flip the fraction, and then step number 2 is it's going to have a positive exponent. Okay, I'm going to apply this exponent 2 to both the numerator and the denominator. Okay, so we get x to the negative 6 over y to the negative 4. Okay, so I'm going to show you a shortcut. If x is to the negative 6, that just means that it's in the denominator, because essentially what this means is that we're dealing with 1 over x to the exponent 6. So what we can do is we can rewrite this with the x to the negative 6 in the denominator, but now we have a positive exponent. So we're just rewriting this as 1 over x to the 6. Okay, likewise, if we have like 1 over y to the negative 4, what we do is this 1 over y, we flip that exponent, or that number, and we get y, and now we have a positive exponent to the 4. So all we have to do is, if something's negative, bring it to the numerator. If something's negative exponent in the numerator, bring it to the denominator. Negative exponent in the denominator, bring it to the numerator. Y to the 4 over x to the 6. Okay, for B, 3xy squared and negative 2y squared. So this is essentially saying that we're going to write this out twice and multiply it. Okay, so we get 9x squared y squared. Okay, because we're adding 1 and 1 on the x's, and we're adding 1 and 1 on the y's. Okay, and of course 3 times 3 is 9. Now, negative 2 times negative 2 is 4. And then we have y squared and y squared, which is y to the 4. Okay, 9 over 4 doesn't divide, so let's just leave it. X squared is the only x value, so let's just leave it. And now we're dealing with y squared over y to the 4. So like, the true way to do it is the exponent in the numerator minus the exponent in the denominator, and we get y to the negative 2. Okay, that's the formal way of doing it. However, we know that y squared is just y times y, and y to the 4 is just y, okay, all multiplied. So if we were to cancel these out, we get 1 over y squared. Okay, essentially, when you subtract these, we get 2, and there's more y's in the denominator, so put it in the denominator. That's the logical way of doing it. Okay, and now C. So we get negative 6 times negative 9. Remember, do the entire numerator first, and then the denominator, and then divide. Okay, so I get 54 this is supposed to be, sorry, that's supposed to be an exponent. Okay, x to the -2 and x to the -5, we add those to get -7. Y to the 1 and y to the -2, 1 plus -2 is just -1. Okay, and the denominator, 3x squared, y to the -4. So let's divide this. 54 divided by 3, I get 18. Okay, now these exponents are a little ugly, so why don't we just go -7 minus 2. We'll do numerator minus the denominator and then worry about where it goes afterward. Okay, and then for the y's, -1 minus -4. So what we're left with is 18x to the -9, y to the -1 plus 4 is 3. We need to rewrite this x to the -9 as a positive exponent. So right now this is technically over 1. In order to do that, we just take that, throw it in the denominator, right? We flip it, and we write that as a positive exponent. Okay, so here's a recall. Negative exponent law. When a number is raised to a negative exponent, we, number 1, flip the number, and then number 2, raise it to a positive exponent. Okay, so when the base is 1 or -1, like what this looks like, so for example, like if it's just like an integer, right, like a over 1, what we do is we still flip this number 1 over a, but this n, it no longer, like 1 to the n, I explained this earlier, but like 1 to the n is just 1. So we actually don't write that the n is here. We just apply to the n to like the integer value. Oh, and this should say a cannot equal 0. Okay, so that denominator can't be 0. Okay, when b doesn't equal 1, so when we actually have a fraction, we flip the fraction and raise the entire thing to the n. So essentially, it's going to be b to the n over a to the n. Okay, and then again, anything that ever existed in the denominator, b or a in this case, cannot equal 0. Okay, so here's some basic questions. 5 is actually over 1, so we flip the number, 1 over 5, and we square it. So now it's a positive exponent. We don't have to worry about squaring the numerator. Okay, so let's flip the number, 1 over -4, and then instead of being to the exponent -3, it's now to the exponent 3. Okay, so what I'm going to do for this one, I'm going to first multiply these. Actually, I'm going to do this backwards because I want to show you guys exponent laws with the negatives. Okay, so the 2 becomes 1 over 2, and the -4 is now positive. So we're dealing with 1 over 2 to the 4. Now that's raised to the exponent -3. So now, because we again have a negative exponent, we're going to flip this number again. So now it's 2 to the 4, technically over 1. And now we raise it to a positive exponent. So, I mean, if we multiplied those, it'd be 2 to the 12th, but I just wanted to go through those 2 steps. You could have gotten 2 to the 12th from the first step. Okay, and the last one. This is an addition, so we're going to solve each individually and then add them. So -3, since there's a negative exponent, turns into 1 over -3 to the positive 4. Okay, so we're going to do that, and then we're going to add 1 over -6, because we flipped the number, and now it's a positive exponent. Okay, so -3 to the exponent 4, I get 81. So we get 1 over 81 plus negative because this is going to be 6 times 6 times 6, negative 216. Um, 648 is the, if you want to do this, multiply the numerator and denominator by 8. I get 8 over 648, and then minus, because we can simplify this by bringing it up. So it's minus, I think it's 3. Yep, 3 over 648. So we're going to get 5 over 648. So if you wanted to go back and evaluate, well, what's 5 squared? Okay, we would get 1 over 25. And then what's negative 4 to the exponent 3? We would get negative 1 over 64. Okay, negative 4 to the 3 is going to yield a negative number, and then we would bring it up to simplify. And then 2 to the 12, oh, it's not that bad of a number, 4,096. So that's actually evaluated. Okay, example 4, simplify. So express your answers using only positive exponents. Okay, so now like moving forward, any answer that you get with an exponent in it, it always has to be positive. Okay, so these three x's are the same base. So what we're going to do is we're just going to add these exponents. So what is negative 5 plus negative 9? Okay, so we have x to the negative 5, and then we're going to add negative 9, and then we're going to add 3. Okay, so when we add all of these integers, negative 5 plus negative 9 plus 3, we get negative 11. So this is just simply x to the negative 11. Here's the problem. We have to write this as a positive exponent. So flip the number, 1 over x, and the 11, since this is just a 1, we can just apply the 11 to the x. Okay, B. There's only a k and an m in the numerator, and then there's a k and an m in the denominator. So we're going to, like the numerator and the denominator are fully simplified. We can skip right to the division, okay? So we're going to subtract 11 minus negative 2, and then we're going to have m negative 4 minus 3. Okay, so I get 11 to the 13, m to the negative 7. We have to write this as a positive exponent. Since it's a negative 7 and all of these are multiplied, we can just bring it into the denominator, okay? Because essentially this is 1 over m to the 7. So we'll get k to the 13 over m to the 7. Okay, and C. We're going to apply this negative 5 onto every single term in the brackets. Well, this is one term. It's a monomial, so every single part of the term, let's say. So we're going to have 4 to the negative 5, p to the negative 3, and that's going to be raised to the negative 5, and q to the 3, and that's going to be raised to the negative 5. Okay, so in our calculators, actually, I'm going to leave this one for right now. 4 to the negative 5. So let's multiply these. I get p to the 15. So that's good. It's positive. And I get q to the negative 15. So 4 to the negative 5 and p to the negative 15 can both go into the denominator. So p to the 15 is going to be in the numerator. And we're going to get 4 to the 5, q to the 15 in the denominator. All we have to do is actually put this into our calculators. 4 to the exponent 5 is 1024. So I get p to the 15 over 1024, and then you just bring down this q to the 15. Okay, example 5, simplify the following. So we have 1 over 6 to the negative 1. So all this actually means is to reciprocate it. So 1 over 6 becomes 6 over 1, all to the 1. Okay, but any number to the 1, you can kind of just ignore that. And then any integer over 1, you can kind of just ignore that. So the answer here is just 6. So in order to flip anything, you just raise it to the -1. Okay, and then this question here, -3/4 to the -3. So we can assume that this negative sign, we can just put it in front of the number. That's totally fine. Okay, because we actually treat 3/4 as like 0.75. That's like a single number. But we want to flip that, so we get 4/3. Okay, and remember, we keep this negative sign because that's part of the number. The number just flips as it is. And now the exponent is written to the positive exponent. Okay, we know from before that this exponent 3 is applied to both the numerator and the denominator. So for simplicity, I just apply the negative sign right to the numerator. So essentially this is going to be -4 to the exponent 3 and then 3 cubed as well. Okay, so we get -64 over 27.